Hello friends, welcome again. So today we are going to discuss. Uh, Let me open the GitHub page. So this is our sucker bucket. I already put it done because I prepared the notes and uploaded the notes into the GitHub repository. Meaning here separate page sucker bucket, right? So if you are new, so this is a high level design series. So we discuss a lot of concepts here. And right now today we are at circuit breaker. Okay, so let's get started. So I think you already know, like, circuit breaker is a very important concept in our distributed system, in distributed systems, right? Meaning, let's understand with the details here. Where I am? Okay, I'm here. So circuit breaker is a design pattern used in distributed system and microservices to prevent cascading failures. The main point is prevention of cascading failures. Instead of sending more and more requests to the failing service, the circuit breaker temporarily stops the service and gives the failure system to time to recover. Okay. Now it works very similar to the electric system in our house. Okay. Just like as too much current flows, breaker trips, electric stop, damage is prevented. Okay. So in software system, same thing. Too many failure requests happen, circuit trips, request are blocked, system damage is prevented. Now let's go with the real world example. Just like I suppose payer summary is down. Thousands of users are trying to pay. Okay. Every request keep retrying. Database connection get exhausted. CPU usage spike. Other services also become slow. This is the cascading failure. Okay, so this is a without circuit breaker. Okay, this is the cascading failure, and circuit breaker prevents the disaster. Okay, this is a kind of disaster. Okay, and circuit breaker will prevent this disaster. Now here, circuit breaker, without circuit breaker, request keep hitting the failure service, keep hitting the failure service. Okay, thread become blocked, memory increases, timeout increases, entire application becomes slow. Other services start failing too. We already discussed, right? Chain reaction is called cascading failure. Circuit breaker helps to isolate this failure. Circuit breaker helps isolate the failure. Okay. No, main goal. What is the main goal? Fail fast instead of failing slowly. Instead of waiting 30 seconds for timeout, inject immediately, return fallback response, protect the system. The main thing is protecting the system. You know, right? We have multiple systems. If you don't have circuit breaker, suppose this is failed and somehow request is going to the failure, 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 failure. So suppose like too much CPU usage going here. Okay, so to prevent that, it will with the circuit breaker, it will say, okay, system is down, so it will not gonna call this, right? It will call another service. So simple concept, right? How circuit breaker works. So we have three stages. This is important. Just uh, bear with me. Closed state, open state. One is half open state. Okay. So closed state means normal state. Everything works properly. Request go to the target service. Example: order service calls, payment service respond successful. Okay. Closed. Open means failure state. Open state means failure state. Now, circuit breaker opens, requests are blocked immediately, 10 requests fail, example, 10 requests fail continuously, failure threshold exceeded, circuit opens. Okay, so this will prevent our system, meaning it will not gonna call the same service again and again. Now, half open. What does it means? After some time, after some wait time, circuit breaker allows few test requests. If successful, circuit close again. If failure, circuit opens again. Okay, kind of this. System will send the request again. If it pass through, it will close. Okay. If not, then it remains open. Okay. Now, life cycle closed, failure increases, open. When it get open, wait time hour, half open. Half open, success, close, half open, failures, open. Okay, whatever we discussed step by step. Now, example scenario food delivery system, restaurant service, payment service, notification service, delivery service. Suppose payment service crashes. Without circuit breaker, millions of requests keep coming. Payment service overloaded, thread blocked, application slow, entire app unstable. Okay, so with circuit breaker, app threshold failure, request stop immediately, fallback message shown. Payment service temporary down, system survives. Okay, now important configuration parameters. First of all, number of failures before opening circuit. Just like as we put 50%, then open the circuit. Time or duration, how long you wait, 30 seconds. Sliding window, check failure hour recent time. Last 20 request. Like how many requests you have to check, meaning 20 request and 20 request of 50%. If it get failed, I'm just giving high level, then circuit will be open. Slow call threshold, even slow responses can trigger breaker. Response greater than 5 seconds, open the circuit. Okay, so four important configuration. Failure threshold, number of failures before threshold, like number of failures before opening circuit, time duration, sliding window, slow call threshold. Now, advantages: prevent cascading failure, improve system stability, faster failure response, source protection, better user experience. Okay, simple. Prevent cascading failure, improve system stability, fast failure response, source protection, better user experience. Disadvantages. So this is a common, right? If you talk about distributed system, additional complexity. That is like mean caching or like anything. It will increase complexity with everything, right? So this is a common. Wrong threshold can cause problem, meaning too sensitive, open unnecessary. Okay, too relaxed, failure continues too long. Now, circuit breaker versus retry. So retry is retrying failed request. Circuit breaker is stop failed request. Retry failed request, stop failed request. Keep in mind. Goal: recover system failure, prevent overload. Recover, prevent. Send more request, block request. Can increase load, reduce load. Okay. Now, circuit breaker plus retry combination. Retry few times, if still failing, circuit breaker open. Usually these works all together, like in the combination only. It doesn't work separately. So popular library we use, like we use Resilience4j. Previously we were using History, but it's now older. It's on Metal mode now. So right now we are using Resilience 4. What it does, circuit breaker, retry, rate limiting, bulkhead. Okay. So we can see some little example. I just included a code as well. Not like proper code, high level code only. So I haven't included the application properties file, just a code, right? So uh, this is a normal code. We are writing just like as this at the circuit breaker name payment service. Okay, so this is a payment in the payment service. We have this method. Okay, if service fails repeatedly, circuit open automatically. Okay, fallback method example just like as usually we write like this. Okay, circuit breaker name payment service fallback method fallback response. In case if this fail like up to our threshold failure, then it will call our fallback method automatically. Okay, so the configuration will be in our application property file, timeout or like whatever the rest properties 5 6 properties are. It will be in application property file, but we have to define like this in our service. Simple. Okay, so Kubernetes, circuit breaker in Kubernetes and cloud. I just include a little bit for an idea. So we have, cloud platform also use circuit breaker concepts like a service mesh, API gateway. We'll discuss later, like, service and what is service. It's again a kind of long concept. So I think if you can ignore this, we already have multiple examples. We can focus on interview questions. Why circuit breaker needed cascading failures? The very first line was cascading failure improve resilience. States, closed, open, half open. Difference between retry and circuit breaker we already discussed. Retries request, circuit breaker blocks request. Okay, we have other like multiple points as well. Okay, we already discussed. What is fallback? Alternate response when service fails. It's a best practice. Use retry carefully. Okay, too many tries can hollow system. Configure proper threshold. Monitor production. Always that monitors just like as Grafana, Kibana, like we usually do, right? Without monitoring system, it don't work. Add meaningful fallbacks. Never show technical errors to the users. Okay, just do some like functionality. Now let's recall our flow client, then we have API gateway, then we have order service, then we have circuit breaker, then we have service fail, then we have open circuit fallback method responded. Okay, so final summary. Circuit breaker is the one of the most important resilience pattern distributed system. Prevent cascading failures, resources, improve stability, helps system recover gracefully. Modern microservices heavily rely on circuit breakers on high reliability and fast tolerance. Okay, so this is our circuit breaker, right? Uh, Important thing is you need to remember cascading failure. Okay, cascading failures. This is the important like word or sentence, whatever. Okay, to prevent cascading failures. Second point is it like a retry plus circuit breaker. Both works together. Both works together. Retry and circuit breaker, and it prevents cascading failure. Never forget these 2 points. Okay. So I'm wrapping up this concept now. So I hope you understand all this. If you have any question, you can uh, like comment on the comment. Otherwise, you can comment like anywhere in like Instagram or like anywhere in any channel, right? If you have another question as well, and you can reach out to me. Any case of design concept you need, or if you have to design anything, just like as any API or any project, whatever you need help, just comment or send a message on Instagram channel. So I will definitely look into it and help you. So thank you so much. And if you're new, then subscribe the channel and you will get notification. Just keep your notification on as well, and you will get regular notification for all the new concepts and all. Okay. So for now, bye for now, and I will see you in the next video. Okay, bye.